Okay, so we look at question 15 as an example of f-test on restricted least square. So this is my original regression. I think output quantity is explained by labor and capital quantities. I do not impose any restriction on any slope parameters. So this is why I can immediately identify this is a unrestricted regression. And then sample size is 123. You can quickly find out the k is equal to 3. R squared must be given to you. And then according to the question, I rerun the regression by imposing a restriction that the labor and capital, they have exactly the same slope parameter. So in other words, I impose a restriction that B2 equals B3. Okay, let's use our mathematical thinking. How I can transform the equation into this actually. Because if B2 equals to B3, then I can change the B3 into B2. And then now these two have the same slope parameters. Remember from your primary school level economics, you can take out the common factor. Then you can actually rerun the regression in this way. Just add labor and capital together. And then I just call it XXX, which is equal to labor plus capital. And this is how I can transform the regression into this way. Log of quantity is a function of XXX, and XXX equals the sum of labor and capital quantity. But subtly, you already realize that according to this information in the question, this is the restricted regression because I impose one restriction on the slope parameter. So let me write it down. That is one restriction is imposed on the slope parameters, that B2 equals B3. So now I want to run the f-test. Is it the correct decision to impose the restriction? So think about using theoretical thinking. If I assume that B2 equals B3, then it means the impact of additional labor and capital quantities on output would be exactly the same. Okay, so think about if B2 equals B3 equals 4, then it actually means if labor increases by 1 unit, the log of output would increase by 4. And then similarly, if capital increases by 1 unit, it would have exactly the same impact on output. That log quantity would increase by 4 units. So I want to know from a statistical point of view, by running the f-test, restricted least square, does it really make sense to impose this restriction? So keep in mind alpha is 1%. Okay, let me copy the equation. Then you can understand my step 2 better. So step 1, you must keep in mind for step 1, we would argue that the restricted regression is correct. So it means it is a correct decision to impose the restriction. We actually don't know for this type of f-test, we really don't know whether the restrictions imposed are correct or not. Okay. Alternative hypothesis means the null hypothesis is not true. Then it actually means the unrestricted regression makes more sense. Step 2, computed f-stat. R squared of the unrestricted regression, 0.67, minus the R squared of the restricted regression, 0.45, divided by M. M stands for the number of restriction. We already know the answer is 1. Divided by all the terms in the denominator relate to unrestricted regressions. So 1 minus the R squared of the unrestricted regression divided by N, 123, minus the K must come from the unrestricted regression, 3. This is how I work out the computed f-stat, 80. Critical f-stat, degrees of freedoms of numerator is hiding here, which is my M, number of restriction, 1. Degrees of freedoms of denominator, N minus K, coming from the unrestricted regression, so 120. 1 and 120, alpha is 1%. So let me uncolor these from the previous question. So 1, 120, alpha is 1%. See. Then your critical f-stat would be 6.85. Okay, 6.85, and since the computed t-stat is way much greater than the critical f-stat, we reject the null hypothesis, meaning the alternative hypothesis is more likely to happen. Then it means the restricted regression is actually no better, meaning it is actually a wrong decision to impose the restriction that the slope parameters of labor and capital are the same. So in other words, it means any one of the two variables should have a greater impact on log of output. In other words, it is the wrong decision to assume that additional quantities of labor and capital would have exactly the same impact on the increase of output, log output in this question. Okay, so this is the third type of F-test, restricted least square. And then for the last type of F-test, it is called child test, mainly on time series regression. So in other words, I want to know, is it a correct decision? We want to run two types of regressions. The first case, we assume no change in the slope parameter during the whole period. Then I run the regression for the full period. Okay, and then in the second case, maybe after doing a graphical sketch, I seems to notice that the slope parameter has an abrupt change. Maybe it becomes steeper from a particular point onwards. So we rather want to run the regression twice for the first period, maybe when the slope is flatter, and then I run the same regression, but for the second time from a particular point onwards. Okay, you see the keywords from a particular point onwards when we notice that the slope parameter has changed. Okay. Okay, and then I don't really think I need the information on the slide, so I think I'm going to do this question from slide 18. I think I need to keep the computed F statistic. Okay, so let's look at that. This is a bivariate regression, but I think in the study guide there is another example, but which is a multivariate regression, but it is still the same old story actually. So the full period is 1990 to 2015. If I really run the regression for the whole period by assuming the slope parameter is the same, then we call this the restricted regression. Okay, keep that in mind. But if I rather decide to run the regression twice, one for each sub-period, then we call them unrestricted regression. So this is the first one from 1990 to 2001, and this is the second one from 2002. So maybe I did a graphical sketch and I seem to notice that the slope parameter of income becomes, let's say, steeper from 2002 onwards. In fact, it is the case if you look at the information actually. Okay. Actually flat, actually. Okay, but it doesn't really matter. The focus is not on looking at the slope parameters. And then to do this child test, I think we need to sort out a lot of basic statistics. Okay, we need to know the residual sum of square, which must be given to you in the question. For the restricted regression, which means I run the regression for the whole period, this restricted residual sum of square, I call it RSSR. It means the residual sum of square from the restricted regression. So this is why it is 23248.3. And then this is my total sample size, and for the whole period, 26. So I hope you are happy with these two statistics. I haven't even started with the F-test. We're still dealing with the preliminary information. And then for the residual sum of square of the two unrestricted regression, we call them RSS1. So this is the residual sum of square from the first unrestricted regression. And then for the other one, it is called RSS2, residual sum of square of the second unrestricted regressions. And then what we need to do is the following. We need to derive RSSUR. It means the total residual sum of square of the two unrestricted regression. All we need to do is to add RSS1 and RSS2 together. This is how we derive the answers, 11790.252. And then the sample size for the first one is N1, and then sample size for the second one is N2. So for the first one, from 1990 to 2001, 12 years. And then for the second period, from 2002 to 2015, 14 years. Okay, so happy with that? By the way, N1 plus N2 must give you the total sample size. So N1 plus N2 must be equal to N. Okay, happy with that? Then we can really do the child test now. 5-step procedure, and then alpha is given as 1%. Step 1, it assumes that the parameter of the slope parameter of the income variable is the same for the whole duration. Then in other words, it means it is better to run it as a restricted regression. Alternative hypothesis means the new hypothesis is not true, meaning the slope parameter of the income variable has changed from this threshold period, 2002. And this is the equation for the computed F statistic. It must be given to you in the formula sheet. It is equal to numerator bracket, residual sum of square from the restricted regression 23248 point something, minus the residual sum of square, the total from the two unrestricted regression. So 11790 something, divided by 2k stands for the number of parameters in the regression. Remember, this is a bivariate regression. So you have a constant and the slope. So 2, k is equal to 2, divided by RSSUR, we already know it, 1179 something, divided by, just be careful with this equation, you must use bracket, n1 12 plus n2 14 minus 2 times k, 2 times 2 gives you 4. So that's 26 minus 4, that gives you 22. Then this is my computed F-stat, 10.6901. Critical F-stat, remember alpha is 1%. Degrees of freedom of numerator is here, 2. Degrees of freedoms of denominator is higher than here, 22. 2 and 22. Alpha is 1%. 2 here. Isn't it 5.72? Yes, 5.72. And since the computed F-stat is greater than the critical F-stat, the new hypothesis is rejected. Then it means the alternative hypothesis takes place, meaning the slope parameter of the income variable is no longer the same from 2002. So in other words, it makes more sense to run two separate regressions as unrestricted regressions. So in other words, the slope parameter of income indeed has changed from this threshold period, 2002 onwards. And then for the last few slides, it is about the interpretation of the E-views regression output, and then they are explained very well on the last few slides and even on the last few pages, quite detailed explanation on the study guide. So I rely on you to do some self-study, and if you still don't fully understand, feel free to visit me during my consultation hours. So we are done with chapter 8, which is quite a exhausting chapter. And then for the next chapter, we will move on to dummy variables, which is an interesting chapter.